Hi, I'm Phil Vashurin from rightmaths, and today I want to talk about motion on an inclined plane. I'm going to start with this question, which is from an A-level maths paper. It tells us that a particle P of mass m is on the inclined plane and it is held at rest. The plane is rough, which just means that there is friction. The angle of inclination is defined by tan alpha is 5/12. The coefficient of friction between the plane and the particle is mu, and mu is less than 5/12. Well, the particle is now released and it starts to slide down the plane. In part A, we're asked to find the magnitude of the normal reaction of the plane on the particle in terms of m, its mass, and g, gravity. Well, the first thing we need to do is to mark the forces on the diagram. Here they are. We've got the normal reaction. Then we need to know that the particle will go down the plane, and so I've marked the friction acting up the plane. Friction always opposes the direction of motion. Lastly, we have the weight of the particle, which is the mass times the gravity, or mg. Now we're asked to find the reaction force, R, and that's perpendicular to the plane. So we need to do a force balance perpendicular to the plane. R and F are perpendicular and along the plane, but mg is in neither of those directions. It's at alpha to the normal. So let's bring in a force diagram resolving the weight mg. We can see that we can resolve mg normal to the plane as mg cos alpha and along the plane as mg sin alpha. That's simple trigonometry. Having done that, we can now equate the two perpendicular forces, so we know that the reaction force must be equal to mg cos alpha, and we have now answered part A of the question. In part B, we're asked to show that as P slides down the plane, the acceleration of P down the plane is given by this expression. Well, we now need to appeal to limiting friction. And limiting friction says that friction is less than or equal to mu times r, where mu is the coefficient of friction. It becomes equal to mu times r when the object is sliding or on the point of sliding. In this case, it has started to slide, so we know that the force is equal to mu times r, which is mu times mg cos alpha. So now we can apply Newton's second law of motion. Newton's second law talks about the rate of change of momentum, but if the mass of the object is constant, then we can simplify the second law to the resultant force of an object is equal to its mass times its acceleration. We need to apply Newton's second law along the plane. The forces are mg sin alpha down the plane and friction, which is acting up the plane because it's opposing the motion down the plane. So mg sine alpha minus f is the mass times the acceleration. We can now see then that mg sine alpha minus mu mg cos alpha equals the mass times the acceleration. The mass is common to all terms, so let's cancel it out, making it a little bit simpler. Unfortunately, we don't know the values of sine alpha and cos alpha, but we do know that tan alpha is 5/12. So I've drawn a right-angled triangle with the opposite and adjacent set to 5 and 12 respectively. Pythagoras tells us that the hypotenuse is 13. Well, that means that sine alpha, which is the opposite over the hypotenuse, is 5/13, and cos, which is the adjacent over the hypotenuse, is 12/13. So we can now write those in. So g times 5/13 minus mu times g times 12 over 13 must equal the acceleration. And if we factorise that, then we have the same equation here that we've got written over here. So that was part B done. Well, part C now asks us to state what would happen to the particle if it is released from rest, but mu is now greater than 5 over 12. Well, to answer that part of the question, we'll just consider mu equals 5 over 12, and let's see what happens to the acceleration. The acceleration is going to be equal to 1 over 13g times 5 minus 12 times 5 over 12. Well, the 12's cancel, and 5 minus 5 is 0, so the acceleration is 0. So for part C, we can see that the particle will remain at rest. I think you can also see that if mu is greater than 5 over 12, then the potential for the friction to resist the motion is even bigger, so again it will remain at rest. So here's the second question, and for a little bit of speed I've added all the important information that isn't shown on the diagram, and I've highlighted it in the yellow boxes. The first piece of information then is that tan alpha is 3/4, and in order to get sine alpha and cos alpha, I've drawn myself a little 3, 4, 5 triangle from Pythagoras and used trigonometry to find sine alpha and cos alpha. I've also marked on the 5 kilograms, which gives a force of 5g, and I've shown the 68.6 newtons, which is a normal reaction force. The x newtons is already shown on the diagram. Now, last time I resolved along the plane and perpendicular to it, and I took my forces and my acceleration in those directions. But this time it's slightly different because I've got an unknown force in the horizontal direction. Now, in order to get round that and not have to include it in my calculations, I'm going to do a force balance in the vertical direction. Now, we need to know then which forces are acting, have a component in the vertical direction. Well, the first force that has a vertical component is the friction, and the vertical component, I hope you can see, is F sine alpha, and that is also added to by the 68.6, and the vertical component of that is 68.6 times cos alpha. And those two forces, their vertical components must be equal to 5g. Well, we know that sine alpha is 3 over 5, so 3 over 5 f plus 68.6 times cos alpha. Well, cos alpha is 4 over 5 is 5 times g, and we're taking that as 9.8 in this instance. Now, if you solve that equation, you will find that F equals minus 9.8 newtons. Now, the question is asking for the magnitude. Okay, well, the magnitude simply means the overall size of the object, so I'm going to write the magnitude of F is equal to 9.8 newtons. Interestingly, it says now state the direction of the frictional force acting on B. Well, I've shown it acting upwards, but I got a negative answer, so part 2 of the question I can answer that it must be acting down the plane. So I'm going to write down the plane. I've shown it up the plane, it came out negative, so it must be a positive force down the plane. Okay, The next part then says find the acceleration of B down the plane, but the x newtons has been removed. So I need to go on and amend my diagram. So here we are, I've amended the diagram and I've crossed out the x newtons. Sine alpha is still 3 over 5 and cos alpha is still 4 over 5, but it tells me the coefficient we now know is 0.5. I'll just underline that for you. The reaction force is no longer 68.6 because we've removed that force of x newtons, and that was increasing the downwards force on the mass of 5 kilograms, and therefore the reaction is going to be bigger as well. So I now need to look at a force balance which is perpendicular to the plane, because R is perpendicular to the plane, so let's do a force balance in that direction. Well, I have to resolve the 5g, and I've done it over here. It's got a component which is perpendicular to the plane, which is 5g cos alpha, and a component along the plane which is 5g sine alpha. Now we can put these two diagrams together in our minds and we can see that this R is balanced against this 5g. So R must be equal to 5g cos alpha. Sorry, I just said 5g before. We need to find the frictional force now, so we can appeal to limiting friction, and we know that it's rolling down the hill because it tells us find the acceleration down the plane. So we know that the force is actually equal to mu, which is 0.5, times the reaction, which is 5g cos alpha. And if you work that out, you'll find it's 19.6 newtons. We've now got all the forces, so we can apply Newton 2 working along the plane. Well, which forces are working along the plane? We've got 5g sine alpha, which is pulling the mass down the plane, and it's being opposed by this frictional force. So we need to take away that, and that resultant force causes a mass times an acceleration, which we know the mass is 5, and times the acceleration. So let's fill in the numbers. So 5 times 9.8 times 3 over 5 minus 19.6 is 5a. And if we work that out, you'll find that a is 9.8. And that's going to be meters. I always write seconds per second squared, but I should really write 9.8 meters seconds to the minus 2. Well, that's the questions done. I hope you enjoyed the video. If you did, then please subscribe to my YouTube channel and also have a look at my website, which is rightmaths.com. Thank you very much for listening. Bye.